pass something back to you, and I think you're missing. Hopefully you can get that fixed right now. For our homework competition, because we're trying to actually do what we're supposed to do, we're going on percent of people that have all of their work turned in. I'd fist bump you if you were part of that list. So if you have all your, now, when was the work due? Friday, right? But I went ahead and said whoever turned in their work yesterday, we'd still count that as on time. Now it's tough for block 3. A lot of their people were gone for ski club, right? So if they didn't think to do it during AO, so here's where I think you got confused, Alex. You're turning in homework that's due this week. That was not what was due last week. This is why we talked about organization yesterday, right? You need to be organized enough to know what is due when, what goes with what. You need to find in your binder last week's homework, the end of chapter 6. I'm quite honestly, my expectations aren't that high. I never collect homework the next day. I hardly ever collect homework even 2 days out unless you've had it a chance to have it before then. So it's not like I'm expecting you to have a fast turnaround. You have CPM homework help and you have Math with Mr. Dell and the entire internet. But I'm telling you, those two sources are probably the best. So, now we are doing better than the Math 7 classes, but that's why we're not competing with them. It's us versus Block 3. So 1B versus 3B, right? 3B's class, it's actually tougher for them. They have 22 students in that class. You guys know how many are in this class? 16, actually. Because we've had a couple schedule changes, and we're trying to balance the schedule, right? This is awkward because right now, if you haven't noticed this, 6 people go over to Mr. Hall for math. That's why your group gets so much smaller. You're my smallest math class, actually. So quite frankly, it should be easier for you guys because there's less of you. However, what that means is each of you is worth more, right? If only 16 of you make up the 100%, and in Block 3, 22 of them make up 100%, each of you is worth a larger percentage. Does that make sense, mathematically? Yeah. So, I'm going to tell you Block 3's percent first, and then you know what you're shooting for to win. If you guys win, everyone's going to get a piece of candy, because I need to start getting rid of this stuff so I can replace it with fresh candy. Block 3. Percent of people who have all their work from last week turned in. Right? And even yesterday counted. Block 3 had a 77%. So the question is, do you guys think in this room, more or less than 77% of us turned in our work? So for our class, 1B, your percentage, I can't even make this dramatic, was 56. 9 of you, 9 of the 16 of you, have your work turned in on time. Which means 7 of you just aren't doing your job or aren't organized enough to know what do I have turned in, what do I not have turned in. Now, of those people, only 3 of you are missing everything, which makes me wonder, why are you that far behind? But none of you, one of you is missing only one thing. Some of you just keep following the trap and not putting your names on papers. Some of you are not paying any attention to what is going to be due on Friday, even though it's written up there all week long. So, I don't know what else to do, guys. I'm offering what I have to offer. If I could literally pay you for doing this, I would try to, but you're not. Some of you aren't doing your job, so you shouldn't be paid. So I guess we'll put the candy away for now. Same offer next week. You guys are 1B versus 3B, right? And 1A versus 3A. Class with the highest percent Gets candy. All right. So you should be looking at who's fastest on that cyclist worksheet. And what is the deal with cyclist A and cyclist B? Why do their graphs start in different spots? So we should be looking at that handout page. So you really needed to grab 3 things from back there. Things that we all did. Now remember, speed, we can't just look at who finishes first. We're looking at who liked the fastest. Speed. What's up? This is CC2712. That's CC3s. This is the chapter we're in right now. I would maybe keep this out, considering this is like current homework. Yeah, that's due this week. I already have you in my book as a check. You did not need to turn that in yet. What I'm confused on is where is your CC3 chapter 6 homework? And I disagree. There is still a 1B paper hanging out over here, but it's old. It's from CC2 chapter 7. Ooh, it looks like a girl's handwriting. Honestly, it looks like Maddie or Beatrix.
Oh, let me see.
I think it looks more like Beatrix than it does like you, but I mean, your handwritings are pretty close. But I mean, I think somebody probably just did this over again.
That's not mine.
Is your 721 still missing in math?
No.
If you think that's yours, put your name on it and turn it in just to get it off the no-name board.
Okay.
But if you did it twice, I mean, that was a waste of your time. But hey, if you want to waste your time.
That was the one I talked to you about, and you said that it was good.
Okay, but either way, I'm trying to clear my no-name board off. Keeps getting too crowded. Alex, where's your binder that you keep your current homework to? Well, if it doesn't have a check on it, it should not be out of your binder. What we're looking for. 624, 5, 6, and the question. Well, can we try to find the others? And can you make sure your name is on that? Do you need to put your name on it or what? I can help work through this folder. You don't need to apologize to me. You're just stressing yourself out by not paying attention to what got turned in or not. And what happens if I don't find them in here, in this step? Where else could they be? Well, where is that? Can you get that and look? That one's a C that you should probably come see me at some point, because I probably put it in as a check, but if I want to see you, it's likely because I just want to make sure you understand what we're talking about. Taking this extra copy that you got from this worksheet. Yeah, but I'm not finding them in here. Alex, can we see if we can find these? Don't you dare get upset about the fact that you made a mistake. Why? One person would have made you guys win. There's 624. And 626. There's all of them. There we go. checklists? Do you need to cross things off when you've done them versus turn them in? Do you need to put a check next to it when it's done and then cross it off when you turn it in? Like, come up with a system. Get motivated. So, not right now, but later, we're going to make sure all three of these are done. Alex, dude, you don't even have this done. It's not like you thought you had it turned in. You didn't even pay attention to did you do it or not. So it's organization. That's what's getting you, is your organization. Are you using your plan book? Well, but are you actually using it? Not just writing in it, but going back and looking at it and saying, oh, this was assigned, did I do it? And I don't know that you are because those homeworks aren't done. And obviously you care if they're done or not done. So I don't think you're using your plan book effectively. Right? I think we need to adjust how we're using our plan book. When we look at biking the triathlon, now your guys' graph has actual labels, but we're going to try to answer through these different questions, right? So I want to make sure that we've actually looked at this and give you another moment or whatever if you need it. But then on the other worksheet, there's also a problem about hiccups per minute. So if you think you've got all these questions done, then go ahead and deal with the hiccups per minute question. But we're going to list the cyclists from slowest to fastest. Then we want to make their rates in kilometers per minute. Then where do the 4 and 6 come from on racer A, right? Why do we see what we see? But honestly, I kind of like working on regular paper. And to make sure that my paper looks like your guys's, because guys, this can go in your binder and be a reference sheet about slope. So if you want to, at the top of this, right, this is our refresher as we're diving back into our chapter about slope and y-intercept. If you are doing anything else right now, you probably shouldn't be. We want to try to figure out not just the slope, but also the entire equation for each of these cyclists. So first card gets the good luck. Gus, you get to pick which cyclist you want to talk to me about. C. Alright, so Gus is going to start with C. I'm going to highlight C so my paper is a real good reference of color-coded, what's going on. Alright, talk to me about cyclist C. Ooh, every 3 minutes. So I think that 3 that Gus is talking about is right here. So if you didn't put a 3 on your paper there yet, I probably would. And you said every 3 minutes they go how far? 2 kilometers. So when we go to make the equation, and guys, I'm going to go ahead and start teaching you guys function notation, even though you don't have to know this yet. Function notation, instead of using y equals, y equals, y equals, y equals, which starts to get confusing, because, well, which y are we talking about? Function notation gives the function an actual name. And then it talks about what's the input we're talking about. So I could either use m for minutes, or I could use t for time. As we're starting this, it's probably easiest to use m for minutes. So what is the slope for cyclist C? Gus, do you know? Because slope, if you need the reminder, slope we talk about as m. If you need this reminder, write it down. And our m is always the ratio of change in y over change in x. Guys, we're making this paper into a reference sheet for you, so you can come back and look at this. So, what was our change in y first? Even though Gus talked about the 3 first, the change in y is 2. The change in x is 3. And then instead of x here, we're actually going to use m. Let's not use m. I regret that choice because m is also slope. Let's not use m because that'll confuse people. Let's just use x. Sorry. C of x. This is why you should be doing math in pencil. Let's call this c of x, and it's 2/3 x. Sorry, immediately regretted my choice there. Just like last night when I made that cut on the table saw, and then I was like, oh, I should not have done that because things splintered out, and I was like, now I gotta sand. It's alright, that's life. Sometimes you immediately regret what you did. Ella, talk to me about a line. You pick which. A. Alright, I'm gonna make that pink. Pink. Alright, Stella, tell me what you know about A. The who-wah-huh thing? The triangle thing. Okay, I see triangle. What about the triangle thing? We've got a delta y. We've got a delta x. So a of x. Sorry, yeah, we're just going to use x as our input. So what's our slope there? 4 over 6. Now, wait a minute. Can 4 over 6 reduce? So if our m is 4 over 6, that can actually reduce to 2/3. So a of x, we can actually say is 2/3 x also? Is that it? Is that the whole equation for a? No, why not, Ella? Ooh, the y-intercept is 7, so we got to pay attention here. B, right, what we're used to calling B in our y equals mx plus b equation. B, quote-unquote B, what we're used to calling B, is 7, so we need a plus 7 out here. If you want to make it fancy, give your 7 a bow tie. Give it a little front hat thing and a little bow tie. That's how you make fancy 7. How what? What? Your sentence is trailing off.
How did it start farther from the beginning?
That's a brilliant question. Why are you asking it, Ahmad? What do you mean? Like, so what is what is upsetting you right now?
Like at the start of how did they at 0 minutes?
Ooh, hold on. Say that when the time is 0 minutes,
They're not at the start of the race.
they're already 7 kilometers in. So either somebody cheated, or maybe somebody's got like a handicap, and guys, hopefully you don't hear that and think like, oh, that's a negative word. Guys, a handicap in like certain sports or golf or whatever, it's like, I'm not as good as everyone else, but I want to compete with those people. So how do we kind of level out the playing field a little bit? We let me start further ahead. Or like in golf, you get to take a few strokes off your score. There's different handicaps depending on what you're doing. But does this look like this cyclist is not as good as it? So maybe they cheated? I don't know what happened, but yeah, you're right. They started at 7 kilometers into the race. Something fishy's going on. Something fishy is going on. Amir, do you want to talk about B or D? B? All right, I'm going to make B green just because it's the next highlighter I had over here. All right, Amir, talk to me about B. So Amir is saying, well, if our delta y is 3 and our delta x is 3 and we set up 3 over 3, that's really just 1. Okay, so our slope for b of x, so if our slope is 1, we can put a 1, or you don't even have to. But wait, is that all of our equation? No. And if I imagine, where would it have crossed the y-axis? Well, guys, if our slope is 1, if the slope is 1, -5, right? Because to get 5, that's not my black pen. Here's my black pen. To go down 5 more, or sorry, to go left 5 more like we want to, we want to go left 5. To go that left 5, we're going to end up down 5. So we're going to be starting at... So what do you think is going on here? Anyone know what a triathlon is? Okay, so in a triathlon... Ooh, now your hand went down. Mick, what's in a triathlon?
It's a marathon of walking.
So normally running, right? But like swim, bike, run. And a lot of times I think because they're like crazy, swim is not the last thing you do, which sucks because you get out of the water and you're like, yay, I'm wet, let's go run. Not great. Or I'm wet, let's go bike. Not great. Right? So like the triathlon's a crazy race. My buddy has ran an Ironman, which is like an insane triathlon. His first one he attempted. He did not finish though. So yeah, it's okay to not succeed the first time, but that doesn't mean stop challenging yourself. But maybe this person had a slow swim, and they're 5 kilometers behind where they should have been. Maybe this person started the race late, but either way, when everybody else was starting out, like, they weren't. They started 5 minutes after everybody else, because I doubt that they're actually 5 kilometers behind, like, they wouldn't be starting 5 kilometers behind everyone, but it could make sense that they started 5 minutes late. Maybe they had to go to the bathroom. Maybe they got out of their swim and they had to go to the bathroom, and now they're finally on their bike, ready to go bike. But, okay, so cyclist B starts later than... Ooh, add this to your equation. We figured out they start at -5. If we were to track the line all the way back. But then, what does cyclist B do? They ride faster. Maybe this was a handicap that they're so good, they made this person wait an extra 5 minutes. Like, literally. Maybe. Owen? Maybe they were just late, but they are really fast. Maybe they didn't care about being on time because they know they're really fast. Now, still, did cyclist B beat cyclist A? Nah. But did cyclist A cheat? Like, I don't know what... If you were to see this graph after a race, you might be asking a couple questions. What is the equation for cyclist D? Anybody, because I need to highlight it. What's our equation for cyclist D? We need that slope, but it does start at 0, 0. So if we analyze their slope, we need nice point to point. So I see a nice point here. I see a nice point here. Oh, they gave it to us over here. They had a 2 and a 4. Oh, hey, 2 and 4 reduces to d of x 1/2 x. And they start at 0, so just 0. Questions on this?
So you would go 2 kilometers every 4 minutes.
Yes, or 1 kilometer every 2 minutes, if we want to say it simpler. I mean, I don't really spend my time watching triathlons, so I don't know how to comment about that. If you need more slope practice and need to ask a friend or come see me or whatever else, we're probably not going to do this problem because like I talked about, like we skipped things, but even if we are going to do it, it's not till tomorrow. So we're not doing the back of this right now. Feel free to use it for extra slope practice if you would like. But now we're going to move on to our 722 paper. Please make sure you skipped the appropriate problems on your paper and put like X's on them or something. On 722, we're going to look here at our hiccups per minute. If you did not know this, I don't want to freak you out, but sometimes people start having hiccups and they don't stop. I'm not joking. There are people who have been documented. It's like in Guinness World Records or whatever, of like their hiccups have gone on for years. And I think it's some sort of like neurological issue where like literally your brain, because like you hiccup for a certain reason, just like you sneeze for a certain reason. But okay, so let's say a classmate of yours got really interested in hiccups, and anytime someone's hiccuping, they start collecting data. Right? Because, of course, we all walk around with, like, stopwatches and notebooks, and we're collecting data.
Simon seems like that type of guy.
So, way to, like, call somebody out for no reason. You can call me out and say, I seem like that kind of... I would be the guy to, like, every time I see Finn, like, measure him and, okay, how many months has it been? Like, the problem that we just had on our mastery. Growth is not linear, by the way. That problem is not a great problem because it's assuming growth is linear. Human growth is not linear. Check out this, like these three different students, answer these three questions here, and if you still have time before I start having us talk together, you can use it to work on homework. Each of these representations is slightly different. We got a table, we got a graph with no grid lines, we got a graph with grid lines. By the way, that's already changed what I wrote for the homework board, and expect it might change again. I'm trying to figure out how we could potentially do like a little lab activity on Friday, and not like don't think like science lab where we're gonna be like chemicals and whatever, but like an experimental like let's act like we're actually doing XYZ. So my hope is to do like 3 and 4 tomorrow, and then obviously we wouldn't also do 3 and 4 Thursday. So my hope would be we do 5 on Thursday and then have Friday for just like a practice kind of, not so much like a mini mastery, but kind of like a mini mastery to check like how good are we feeling about this. Okay, moving on. Owen, pick one of these students to talk to me about in hiccups per minute.
So student 1, I can see that when you go from 2 to 4 in minutes, the number of hiccups increases by 8. So I know if you were to go from 2 to 3, then it would just be 8 divided by 2, which is 4.
Hey guys. Student 1 and student 2 show us two very different situations. Student 1, what Owen just said is he looked at this goes up by 8 and this goes up by 2. So if I went down 8 and down 2, I would actually end up at 0 minutes, 0 hiccups, which that makes sense. Would student B have 0 minutes, 0 hiccups? No, because their y-intercept, so something happened that they've already been hiccuping when we started the timer. You cannot take a moment, get over what you think is funny, because this matters. You cannot just take the y over the x. That will sometimes work, not always. What we need to do is evaluate a change in y. So I need to look at 2 different y values and the change between them. The change in x, which is what we're looking at right over here. Change in y, change in x. But the dangerous thing is when you see a table, if you just do y divided by x, that's not always your slope. Because what if they didn't start at 0, 0? You can't just do that. So I forget if it's this homework or what homework, you're going to see a situation like that where, like, if you just did the y value divided by the x value, your slope will be different than if you do change in y, change in x. Here it would actually be the same because we're still kind of giving you the nicer problems. If we made a table out of student 2, that would not work. But what is our slope for student 1 in hiccups per minute? 4, right? Because if we do 8 over 2, 4 hiccups per minute. So student 2, Cora, can you talk to me about student 2? Sure. Beatrix? So here, this quote-unquote is not the y value, it's the change in y. They are showing you that that is the delta y. This is the delta x. So don't get spooked that I said if this was in a table, your table wouldn't have 7 and it wouldn't have 2. It would maybe go from like 1x up to 3 for your x. Or like from 5 on your y up to 12 on your y. Like your table wouldn't have 2 and 7, but the growth triangle is showing us delta y and delta x. So it is 7 and 2 that we can use, which would reduce to what? 3.5, right? 3.5, 3.5. So student 3, with this beautiful tracked data and growth triangles that we see there. What, Amir? Because it's not happening exactly on the minute. So it's not half a hiccup, it's the fact that it's not a perfect amount of minutes. So if you follow it for 2 minutes, he hiccuped 7 times. It's not like he went, stopped halfway through and then waited, like, no, come on. Like, all right, so then student 3, anybody, what's their slope? 3.8, because the delta y right here is 3.8 over the delta x of 1. 3.8 over 1 feels kind of silly. It's just 3.8. So who's got it worst here? Who's got the most hiccups per minute?
First one.
Yeah, student 1. And guys, I hope that we could be able to tell the answer to part C. If we were to graph student 1, would it be steeper, not as steep? Steeper, right? Because the higher the slope is, the steeper it is. I want to remind you, before we get out of here, because I have 1 minute, Desmos is not just a site where we go for activities, which we will do that other Desmos activity at some point this week. Like, it's not super critical. Guys, look up here. If you just want to play with, okay, what's a slope of 2x look like versus a slope of 5x? Or, look up here, you could set a slider in M, or in Desmos, to play with what happens as I change M. You could also set a slider for the B value and play with what happens as I change my B value. Oh, I go up or I go down. Like, the graphing calculator in Desmos is a great tool to use with your homework if you just want to quickly be able to throw something in a graph and be like, what's this look like? What happens if I change this? Because, like, you're not going to break anything here. Trust me, Alex in 8th grade has done crazy graphs in Desmos. He's only ever broken Desmos once, but that's because his graph was too close to infinity. You can't reach infinity, so infinity breaks math. So does dividing by 0. Don't do it. Breaks math. All right, have a great day. Get out of here, guys. It does. It doesn't. Like with you saying what does, it doesn't. Like nothing happens because it doesn't.
You're dividing nothing in half.
No, you're dividing by nothing. So if I walk in with 5 pizzas and I say I'm going to split these 5 pizzas to nobody, I disappear. Everybody disappears. There are no people to eat the pizza. And then the pizza doesn't matter because if there's no people, if there's no people to eat the pizza, then the pizza doesn't matter. And Cookie Monster's sad there are no cookies. And you're sad that you have no friends. Well, that's what the video that we watched said. Hey, do I remember us watching that video about what happens when you divide by 0? You used to, if you asked Siri to divide by 0, thanks you too, it played this silly thing about Cookie Monster and trying to divide cookies by like 0 friends. So yeah, they got rid of it because like mathematically it wasn't helping people actually like really understand what was happening. People were just like, oh, that's funny. But it was talking about 0 divided by 0, which is actually a whole different thing.
What?
Because that then gets in conflict with the other math rule that any number divided by itself is 1. However, 0 is not really like a value. It's the value that represents not having any value. So the whole any number divided by itself is 1 applies when that number is not 0. Right? So there's like a little asterisk on the math rule of like as long as the number isn't 0. It's a whole thing. Math is hard.
And 0 is bit year.
And 0 is what?
Bit